if your curiosity is not strong enough to watch this part 1, skip to part 2. It's useful. It gets your mind thinking the right way in understanding where something comes from. I'm not going to make it too deep. It's going to be quite superficial. Going to begin by using my usual trick of let's have a look on the internet. Wonderful thing. Pi, there's your symbol for pi. If it's written, it's normally uppercase P, lowercase I. There's all sorts of values people suggest you use, but pi is one of those numbers that, hang on a minute, can I move this? Here we go. That's meant to be your decimal point. They put a comma. 3.141, and look at the number of decimal values that are in it. It's one of those special numbers where the decimals never ever stop. They go on forever and ever and ever. They really do not stop. Special numbers called irrational numbers. All right, pi is one of those. Sometimes they use a fraction to represent pi. When I was at school, this one here was quite commonly used, 22/7. It is not the exact value. It's close, but it's not the exact. This one here is even closer still. I don't know why they've repeated it. That one is closer still. You know, there's a number of fractions that can represent pi. This 22/7 is quite easy to remember. You may come across it, you may be asked to use it, you may not. It all boils down to angles. You have your circle and you get two lines coming down to the center, and between those two lines, those two radii, you have an angle. The units of measurement that I'm aware of for angles are these three here. Degrees, you will know about. Radians, we're going to be talking about. And revolutions, I'm looking at the wrong one, hang on, down here, radians, rads, degrees you're used to, something called grads. Now they're not very often used at all. If I remember correctly, 90 degrees is worth 100 grads, but we're not going there, we're not using it. What we're going to be looking at is we're going to be looking at radians. These are very important when it comes to thinking about pi. Okay, we begin by pulling up a circle, which is not showing. Why is it not showing? Please show. Alright, hopefully this works. Okay, let's draw a line from there to there. Now I'm going to try and judge it by eye. From there, say, where should we go? About there. Right, that's an approximation. This is your radius. It has a particular size. When I'm going to do my best, this distance all the way around here, actually on the line of the perimeter, when that length there, this length here, is the same as the radius, that angle there is 1 radian. I'm going to put rad. 1 radian is when the distance along the curve of the circle is the same as the radius. That is 1 radian. And there are pi radians equals 180 degrees. We have, for area, these are the equations. Area is equal to pi r squared, and the distance all the way round on the perimeter. Alright, so the perimeter or the circumference, I'll put perimeter, alright, is equal to pi times the diameter, or if you like, 2 times the radius, which is the same as, and you usually put the number in front 2 pi r. That is the same as that. Right? Those are the equations. Now, where it's fair enough to say there are pi radians in 180 degrees, and it is fair enough to say that the perimeter, I'm not going to go too deeply into it, is pi times the diameter. That you can work it out knowing that there are pi radians, and you know what the radius is, and you can work out what the distance all the way round is. It all boils down to the radius is the same as the distance along the curve. How do they get the area? Do we really want to go into that? I'll give you a quick overview, and I'm not going to go too deeply into it at all. I'm just going to give you the beginnings of an idea. Opening up my drawing package, we have this here. How can I do it? Let me think for a moment. Well, we've got to start by drawing a circle. Okay, so let's make the size of the lines quite thick, and I'm going to make them solid. And what colour do I make the outer one? Let's make it a red, shall we? Right, let's draw our first circle, and we get this shape here, nice and thick. We know the radius, so we can work out all the distance around. That's the key point. We can work out all the distance around, the length of the red line. Let's change the colour now. Let's change the colour. What should we go for? Let's go for blue. So it's going to be a 6 point, and it's going to be blue. Draw another circle. I'm going to try and get this to work as best as I can. Right, now let's move that so the centres are together. At least I'll try to. Good doggy. Ah, yeah, excellent, excellent. Oh, hang on a minute. I've got to stop it from controlling where it goes. I want to put it where I wish to. Alright, I'm doing the best I can to line that up. Now, suppose we were to move... Oh, no, I've got to move that, haven't I? Such that the two lines touch as best I can, alright? So there's no gap. We can now work out the length of the blue. We can work out the red, the length of the red, the length of the blue. So we can work out every single length as we come closer and closer and closer to the center. If we add them all up, we get the surface area of a circle. This is where it comes from. They use a branch of mathematics called calculus to add them all up. We're not going anywhere near that. Right? So this is what it's about. It's about adding up all the circles until we get the complete surface area of the thing. That will give you an idea of what it's about. Now we can move on to part 2.